This is another problem on fractions, and basically you can say that these are all are involving proper fractions. So in these three diagrams, you have to identify the error. What's the error? If there is any, then that is the statement that's written here. So if you see this triangle, now clearly this triangle has been divided into two parts. Are they equal? You can see that no, this is of different shape, and this shaded portion. The shaded portion is of different shape, right? So if you in a triangle, if I draw a line and I have divided these into two different parts, and those two different parts are not equal, they are of different shape. This is of triangle and this is a trapezium shaped. Okay, therefore can you say that this is 1 by 2? Because you know that by definition of fraction, if we divide any object into two equal parts, then it can be, if one part is then shaded, then we can say that that is 1 by 2. But in this question you can clearly see that though it's a single object which has been divided into two parts, but those two parts are not equal. This is something is of different shape, this is of different shape, and therefore this shaded portion is definitely not this 1 by 2. Therefore we cannot say what fraction it is, because it's these two parts are of equal or different shape. What about this one? Again, this is a single object which has been divided into four parts. But are they equal parts? You will say no, they are not equal parts. This part and this part is equal, right? But this part and this part are equal. But all is this the condition where all four parts are equal? No, it's not such condition where all four parts are equal. Two parts are equal and another two sets of two parts are equal, but all four are not equal. Therefore, again, this shaded portion cannot represent 1 by 4. Had it been the case where this particular square or whatever it is was divided into four equal parts, something like this. Let's say that this is our square and it was divided into four equal parts. Then if we had to take this shaded portion, then we can say that since it has been divided into four equal parts, therefore this one shaded portion will represent 1 by 4. But in this case, again, similar to what we discussed here, in this diagram also, these four parts, all the four parts are of not equal area or shape, whatever. Therefore, this is not 1 by 4. This is wrong, error, and this is also wrong. What about this one? This is a circle. You can take it as a pizza. And has this pizza been divided into equal parts? Definitely not. This is a bigger part. This is another bigger part. Different shape. This is another different shape which is smaller to this one. And this is of some different shape. So this particular circle has not been divided into equal parts. All are of different shape and size. Therefore, definitely these three shaded portions cannot be said to be a fraction of 3 by 4. Had it been the case that, let's suppose that this is a perfect circle, just suppose that this is a perfect circle, okay, and it was divided into four equal parts, Suppose that it's a circle and divided into four equal parts, and if it was asked about these three shaded portions, then you can say that this is 3 by 4, because circle was divided into four equal parts and we are taking three shaded portions, therefore this will be 3 by 4. But this is definitely not the case where this circle has been divided into equal parts, therefore it's also an error. So that is the important thing, right? Whenever you are looking at any diagram, the first and foremost condition of a factor of any diagram to be considered for fraction is that all the diagrams have been divided. If they have been divided, then they are divided into equal parts. and not different shape or size parts, right? That's why all these three are wrong.